Hi everyone. Today I am going to talk about the trigonometric identities. This is something feels to be very difficult part of class 10th trigonometry because you know and also understand the introduction of trigonometries and some particular values at angle of trigonometry in very easy way. But it seems to be difficult because it is related to the proof. So I am going to give you the ultimate of the proving in this video, so that after that you could make the use your mind and able to prove all the question related to this chapter. So how you have to use, mainly for this you have to remember the three identities which you have studied in the introduction. So what is these identities? As I think you know, the sine square of theta plus cos square of theta is equal to 1. This is the first identities, and the second is equal to 1 plus cot square of theta is equal to cosec square of theta, and the third identity is 1 plus tan square of theta is equal to sec square of theta. I think you know this. These are the three basic identities which you have to use to prove all the question which you related to the trigonometric identities. And one more relation, which is the tan of theta is equal to sine theta by cos theta by cos theta. This is also important thing. So how you have to approach the question? First of all, I would like to tell you, whenever you are going to prove the any trigonometric related to the trigonometric identities, just you have to find out whether are you getting anything. Just suppose if we have to find the 1 minus sine square of theta, this is the first question, into the sec square of theta is equal to 1. That means we have to solve this side and get the answer 1. So that means we have to prove that this side is also equals to 1. So in the trigonometric identities you could prove in the three ways. Either you solve the LHS, either you solve the RHS, and either you solve the little bit this one and little bit this one. So that means you could solve by this one or go through this one and by both of them. So we have the three way to proving the trigonometric identities. But in this you are able to see that we have to go through this conclusion. So it's become a very easy to go from this one to this one. So in the 90% or 99% of the question, you have to go from the LHS to the RHS and not to start with the RHS. This is the first thing which you have to remember. And the another thing which you have to remember when you are proving any question, if you are getting the squares of any function, the sine, cos, tan, then you have to use the identities, this identity. And if you are not getting the any type of a square, not getting the any type of a square, and let the question is in the cos theta, sin theta, cosec theta, then you have to try to convert all those ratios into in the form of sine by sine and cos, so that you could solve to this. Like this, in this question you are able to see that there is no square in the function. So what you have to do, it is already in cos, then it is right, but tan theta can be written as sine by cos, and here the cot theta also can be written as the cos by sine, because the tan theta is the sine by cos and the tan theta opposite is the cot theta, so it can be written as cos by sine. So I think you understand how you have to approach the question. So as you are able to see that here we have in the squares, so we have not to convert anything into the sine, cos like this. So what is the 1 minus sine square theta? So as we know this identity, the sine square of theta is equal to plus cos square of theta is equal to 1. So if you remember this identity, then you will be able to prove this very easily. So as you could write here, the cos square of theta can be written as 1 minus sine square of theta using these identities. So 1 minus sine square theta is equal to cos square theta. So here you could write the cos square theta, cos theta, and here we have the sec square theta, and which you have to prove equal to the 1. So how will you approach now? So as you know that cos theta, let's suppose write the cos theta, and what is the sec theta? Sec theta is the reciprocal of the cos theta. That means sec theta can be written as the 1 by cos square of theta, because it is the opposite or the reciprocal of cos theta, so it can be written as 1 by cos square of theta. So cos square theta and cos square theta will be cancel out, then we will get the answer 1. So this is what we have to prove. So I think you understand how we approach this question. When we see the squares in the function, we have to use the identities. If we are not watching any type of the squares in the function, then we have to convert all those identity in the sine and cos. Let's try the another question using this thing. So as we solve the first one, and let's see the second question, which is the 1 plus tan square of theta is equal to 1 minus sine theta is equal to 1 plus sine of theta is equal to 1. So how you have to approach this question? As you know that 1 plus tan square of theta, from here 1 plus tan square theta, it can be written as the sec square of theta. That's good, this can be right. And remaining part is the 1 minus sine square of theta, which is 1 plus sine square of theta is equal to 1. You have to prove. So you have to prove that this side is also 1. So how will you approach this? You are watching here that we have the squares in the function, then you convert it according to the formula. But here is no squares in the function. So if you are able to observe that it is written like the a minus b and into a plus b. Let's suppose we have this one is the b and this one is the a, this one is the a and this one is the b. So it is a minus b, a plus b, and this is the basic identity which you have studied in class 8 and 9, that is a minus b into a plus b, which is equal to a square minus b square. So using this identity, you could write here the sec square theta, which is already written, and it can be written as 1 square minus sine square of theta using this identity, and this can be written as sec square of theta. The a square of 1 is equals to the 1, so 1 minus sine square of theta it's become. And what is the 1 minus sine square of theta? So as you have to this, as you get this one in the square form, then you have to use the identities. So as you are able to using the first identities, when you kept here this side the cos square theta, this becomes this side and it becomes the 1 minus sine square of theta. So the 1 minus sine square of theta becomes the cos square of theta. So right here the sec square of theta, and this part can be written as the cos square of theta, and which you have to prove is equal to 1, and sec square of theta right as it is, and the reciprocal of the cos square theta is also 1 by sec square of theta, and sec square of theta and sec square theta will be cancelled out, then we will get the answer 1. So as we able to prove this one also by this simple method. And let's try the another question. So this is the basic thing which you have to observe when you are proving or playing with the proofs of the identity. So as we have done the 2 question, and let's try the third question, which is the sec square of theta minus 1, which is equal to 1 minus cosec square of theta, which is equal to minus of 1. This is the, I think, written here wrong. Here we have to write the minus of 1. So how will you handle this one? So as you know that we have the squares here also and here also, that means we could use the identities. But what we have to write as the place of sec square theta minus 1. So as you are able to see that in this identity you have the sec square of theta. So right here the 1 plus tan square of theta is equal to sec square of theta using this identity. But now you have to find here. So if you remain here the tan square of theta, it's become the sec square of theta minus 1. So if we go this side, right side, so it become in the minus. So as you are able to see that sec square of theta minus 1 can be is equal to the tan square of theta. So right here the tan square of theta, and this is the 1 minus cosec square of theta is equal to minus 1, which you have to prove. So now this is also in the form of a squares, function are in the form of squares. Now you have to use the identity. So which identity you are going to use? In which the cos square of theta is given. So as we have the identity 1 plus cos square of theta is equal to cosec square of theta. So this is what we have to bring here. So as we have to bring, so this can be written as cos square of theta is equal to cosec square of theta minus 1. So this can be written. But if you observe what is the question asking to you, here the 1 is in the plus and cosec square theta is in the minus. But here the cosec square theta is in plus and 1 which is in the minus. But here answer you have to provide in the opposite sign. That means you have to make this one as minus and this one is plus. So what will you do? So if you will take the minus as a common, so if you will take the minus as a common, that means when you will take the minus common, then it become the 1 plus 1 minus cosec square of theta. When you take the minus as a common and this minus as a common, when you take, so it become like this. So this one, let's suppose this one we have to write the this one, what will you write as the place? So now it's become the 1 minus cosec square of theta. At this place we have to write the minus cot square of theta. So as we get here the tan square of theta and here we get the minus cot square of theta. So as you know that tan square of theta and it's this the minus multiplies, so here you could write here the minus as a whole here, and the cot square of theta is the reciprocal to the tan square of theta. So the cot square of theta can be written as the 1 minus tan square 1 by tan square theta. Tan square theta, cot square theta will and 10 by 10 will be cancel out. So here we will get the answer as a minus 1. So I think you understand how we get this answer. Now try the another question which is related to this. So as we have done the 3 question, so now go over the 4th question, which is the sin theta minus of cosec theta, which is multiplies the cos theta minus sec theta, which is a 1 plus tan theta plus cot theta. This is what you have to prove. As I said, in the 99% of the question, you have to go from the LHS and to prove the RHS. So this is because it is the very simple way to prove the trigonometric identities. So now you are not getting the any type of squares. So as I mentioned that if you are getting the squares in the function, then you have to use the identities. But when you are not getting the squares in the function, on that case you have to convert all those trigonometric function in the form of sine and cos. What I am saying, just remember this. If you are not getting in the form of squares, then you have to convert all those ratios in the form of sine and cos. So as we have, this one is already in the sine and this one is in the cosec. So this one can be converted in the sine because the cosec reciprocal is the sine. So write here the sine theta and the reciprocal of cosec written as the 1 by sine theta. So this become, now we have the cos here also and the sec can be written as the 1 by cos. So as I mentioned, when you are not getting the squares, then you have to convert those identity in the form of sine and cos function. Now you get here, now you get to this conclusion. Now what you are thinking to do so, when you are able to see this is something like a fraction, so you have to take the LCM. Now the same thing you have to do here also. Taking the LCM, what is the LCM? LCM will be sine of theta and here become the sine square of theta minus 1. I think you know how to take the LCM because this is very basic thing which you have studied in class 3, 4, 5, 6. And taking the LCM here, the cos square of cos theta, we will get here the cos square of theta minus 1. So as we get to this conclusion, and the sine square of theta minus 1, as we get in the square form, this can be written as the cos square of theta, as I teach you earlier. This can be written as cos square of theta into me by sine theta from this one, and into, so cos square of theta minus 1 can be written as the sine square of theta. Sine square of theta and cos theta is as it is cos theta. So as we get to this conclusion, now what is the meaning? 1 cos square theta into, what is the here, the cos square of theta, that means cos of theta into cos of theta, that means 2 times it is written. So 1 time it's cancel 1 and 1 time cancel also here also. So what we get? So here we get the cos theta into sine theta. This is what we get from here. Now you are thinking that further this cannot be solved because it will mix up. So now when you solve the LHS, you are not getting to the final answer. Then you have to proceed with the RHS also. As I mentioned, we have to use the 3 ways. First of all, we have to solve the LHS. If you get to the answer, then write. And if you are not getting, then you have to solve the little bit RHS. So as we solve the LHS, that means left hand side, we get the cos theta into sine theta. But we are not getting the answer because this side you have to prove tan theta plus cot theta. That means this side we have to also solve because we are not getting to this one. So as I mentioned you, when you are not getting the squares in any trigonometric function, then all you have to do is to convert into the sine and cos function. So the tan theta can be written as sine y cos, as I teach you earlier. So this can be written as the sine theta by cos theta plus cot theta is the reciprocal of tan theta. So write here the reciprocal cos theta by sine of theta. So taking the LCM, we get the cos theta into sine theta, and this can be written as the sine square of theta plus cos square of theta. And as I think the sine square of theta and cos square of theta, from the first identity we get the 1. So this can be written as 1 by cos theta and into sine theta. So as we get here the 1 into 1 by cos theta into sine theta. So as we multiply this one here and this become to this here. So as we get here also the cos theta into sine theta when we solve the this side. So when you solve the this side, you get the cos theta into sine theta, and when you solve the this side, you get the cos theta into sine theta. That means the RHS is also cos theta into sine theta, and LHS is also cos theta into sine theta. That means both become equal. So this is what we need to prove. You have to make both sides the equal. So I think you understood how we have to proceed in the questions. So just try the another one. I think this sometimes being so difficult for the students, but now when you use your mind and when you are understood how we have to proceed the question, then you will be able to done it in a very easy way. Now we have to prove this one, the cos theta plus 1 minus tan of theta plus sin theta into 1 minus cot of theta, which is equal to cos theta plus sin theta. This is what you have to prove. So see and watch and observe, then you will able to solve the question. Are you getting any squares in the function? No. That means you have not to use the identities directly. So you are not getting in the form of a squares. So now what you have to do, the next thing, you have to convert all those function, trigonometric function, in the form of sine theta and cos theta. So as we have to convert, so right here the cos theta, as we have already in the cos, and which is have to convert, and the sine tan theta can be written as sine theta by cos theta using these identities. So right here this one, and it's become the sine theta and the cot theta. As you know that cot theta is the reciprocal of the tan theta, or you could write here also the cot theta is equal to cos theta by sine theta, because its reciprocal is like this. So this can be written as cos theta by sine theta. And when you get in the form of fractions, then you have to take the LCM. So when you will take here the LCM cos theta, it become also the cos theta, and here it's become the sine theta. So as you get this one here, so as you now have to solve this, taking the LCM here, the sine theta you will get here the sine theta minus cos of theta. So as you get to this conclusion, so what we have to do next? So as we here the cos theta upon my cos theta minus of sine theta by my cos theta, this is what we have, and in plus we have the sine theta 1 minus cos of theta here we have the sine theta minus cos theta, and then we have the sine theta. Now as you know by the mathematics, this is multiplied to this side and it's remaining the denominator, and this multiplied to this side. So now I am going to write here, so when it's multiply the cos into cos, it become the cos square. So it can be, and here we have the cos theta minus of sine theta, and here plus in we have the sine square of theta, and here we have the sine theta minus of cos theta. So as you get to this conclusion now, but even though you are not getting to the answer which you have to prove the cos theta plus sine theta, so how will you proceed? So as you know that if I will write here the 1 by 2 and the 5 by 2, when the denominator is the same, then LCM remains the 2. So like this you are getting here the cos and sine, and here also the sine and cos. But when you observe that the signs are in the negative or opposite, like the cos theta here we have in plus, but here the cos theta in the minus. So what can you do to making the sign both the side equivalent? So taking here the minus common, so it become the minus sine theta and become the plus sine theta. As you know that the sine theta here it's become the minus, so this minus sign transmitted here, so it become like this. So as we get here the also here we have also minus sine theta, and here we have also minus sine theta, here we have the plus cos theta, and here we have the plus cos theta. That means LCM is going to cos theta minus of sine theta. When we take this one as an LCM, so here we will get the cos square of theta and the minus sine square of theta. So this is what we get, which is the cos square of theta minus sine square of theta. Now how you have to proceed now onward? So as you know that as we reaches to this point, and as you know that it is written like the a square minus b square, the identities of a square minus b square is like a plus b into a minus b. So as we also here, let's suppose this is the a square and this is the b square, so this can be written as expanded as cos theta plus sine theta into cos theta minus sine theta by cos theta minus of sine theta. Like this it is going to expanded. As you know that cos theta minus sine theta will be cancel out here, and we have remained with this one, which is the cos theta plus tan theta, cos theta plus sine theta. So as we remain with this one, so this is what we have to prove this side, and as we get to this conclusion, so as you are able to think that this is somewhere a large and huge question and something a little difficult, but what we have to do, did here. So as we taking that, if you are not getting the squares, then you have to convert in the sine and cos, and when you get in the fraction you have to take the LCM. Now just watch and carefully, if you are getting the remembering any identities, you have to use the identities. This is how you will able to prove all those things, and I think you understood, and thank you for today. And this is a homework question for you, and if you are not able to solve, I will solve in the next class, and thank you for today.